All right, now we are set. Oh, what did I just do there? There we go. All right, let's do a couple examples. This is real basic stuff. We haven't even come close to doing like real, quote, Algebra 2 stuff yet. It's just been real basic review, but it'll get to there soon enough. So enjoy the Algebra 1 review that we've been doing before we get to the Algebra 2 stuff. All right, so here's an example, and it's super easy. What's that? Negative 30, right? Because the rule says if you're multiplying, you got different signs, your answer is always negative. If they're the same sign, your answer is always what? What if it was negative 5 times negative 6? Then this would be what? Positive 30, correct. Okay? Part B, they just throw a decimal in there just to make it a little bit tougher for you. What's the rule? This is addition, but you're adding two different signs. So really, what are you doing to those two numbers? Are you really adding 10.1 and 2.4? Yeah, you subtract those and you take the sign of the bigger number. So what's my sign going to be? Positive, right, because 10.1 is bigger, so that's going to be positive. So I'll do the work for you. That's 7.7, and your answer is going to be positive. Simple as that. Let's do another one. It's super easy. 34 minus, and then they put this in parentheses. What's the rule for subtraction? For the rule for subtraction, add the opposite. That's right. So we turn this into add, then we add the opposite. What's the opposite of negative 5? Positive 5. So really, we're just going 34 plus 5 is 39. All right, now they throw a decimal, or not a decimal, but a fraction at you. I guess you could consider it a decimal. That's supposed to be a 2. That's kind of weird looking. Negative 2/3 divided by negative 4/5. Right now, let's just look at the sign. What's the sign of this answer going to be? It's division, which is the same rule for multiplication. You got the same sign, so what's the sign of my answer going to be? It's going to be positive. So really all we got to do is do this. Do you remember how to do division of fractions? You flip. So you turn this into what? Multiplication, and then you, right. So I always said this. I always say you multiply by the reciprocal or inverse. Either way, same thing. Okay, multiply by the inverse or multiply by the reciprocal. All right, so it's 2/3 times what? 5/4. Now, yeah, technically I should put negatives there, but I know my answer is going to be positive, right? So I'm just going to lose the negatives right now. So how do we do that? We could just multiply across, but what's a better way to do it? See if anything cancels out. Does anything cancel out? Yeah, the 2 and the 4. So the 2 goes once, that goes twice. Anything else cancel? Nope. So what is it? 5/6. So on the homework problems, if there's work to be shown, like on this stuff right here, there's really no work to show, right? On A and C. Maybe on B, you might want to go like 10.1 minus 2.4 and, do all that kind of stuff. Okay, you might want to do that. But here's a little work to show right there, so make sure you do it. One more with fractions. This is the last one of these, and we'll go to something a little different. So this is negative 1/3 minus 3/4 plus 3. Just a plain old 3. Why don't you try that? I'll give you like 1 minute, okay? I want you to try it and come up with an answer. Ready? Go. Show the work. Write it down in your notes. So it's negative 1/3 minus 3/4 plus 3. Multiplying and dividing fractions are usually a lot easier. Adding and subtracting, though, that's the one that's probably the toughest. But see if you remember how to add these without a calculator. Everybody should be writing down stuff. At least write the problem down. Ten seconds. All right, that's a minute. I think it was a minute. Close to it. All right, what do we do? First of all, here's what I would do. I would make this into, I'm just going to put it over 1 for right now, okay? And so what do we have to do? We got to find a common, what's the phrase or word? Denominator. That's right, common denominator. So watch, I'm going to put a little, there's a minus right there. There's a fraction. There's a plus. There's a fraction. So I got 3 and 4. What number, and I'm not here to teach fractions, okay? I'm just trying to remind you a little bit. But what number does 3 and 4, what's the smallest number that 3 and 4 divide into evenly? 12, that's right. So I'm going to put a 12 here, a 12 here, and a 12 here. All right, so what did we do to that 3? What did we multiply that 3 by in order to get to 12? Multiply it by 4. So you multiply the top by 4, so what do you get? Minus 4. Okay? What do we do to this 4 in order to get to 12? We multiplied it by 3. So you multiply the top by 3. We could write it in there, but 3 times 3 is 9. What do we do to 1 to get to 12? Multiply it by 12. 3 times 12 is 36. Okay? Now that we have a common denominator, all we got to do is add up the numerators. So let's do that. It's negative 4 minus 9. What do we do with that minus? Add the what? Opposite. So what's negative 4 plus negative 9? I'll just do a little work down here. That's negative 13, right? Plus what? 36. What do we do with these two numbers? It's an addition problem, but they're different signs. So what do we do? Subtract, take the sign of the larger. So 36 minus 13, what's that? 3 minus 1 is 2. 6 minus 3 is 3. So it's, what's that, 23? And it's positive, right? Because 36 is the biggest number. Does this reduce at all? Does anything divide evenly into 12 and 23? Nope, so we just leave it like that. Now, some of you might be tempted to do what to this? Yeah, to make it an improper or a mixed number, all right? You don't have to. They drilled this into you when you're a little kid, didn't they? When you first learn, I don't know what year you learn fractions, middle school, maybe 5th grade, something like that, I don't know. But they probably drilled it into you. Never leave it an improper fraction. Once you start getting into algebra, improper fractions are perfectly fine. All right, there are times, absolutely, when you want to turn it into a mixed number. But for the most part, an improper fraction is fine if you really, really wanted to. How would you do this? How many times does 12 go into 23? Just once, right? And then you subtract. 23 minus 12 is 11 twelfths. Okay, that's fine. But that's just one more step you have to do. And the least number of steps that you have to do, the better. Wouldn't you agree? Yeah, I think so. So keep it 23 over 12. As long as it's reduced. There's nothing that divides into either one of those, so just keep it like that. This is fine. You just don't need to do it. This technically is not reduced. That's a lot of, especially elementary teachers, they'll say, oh, reduce this. Oh, it reduces to 1 and 11 twelfths. No, it doesn't. It just changes the form of it from an improper to a mixed. I'm fine keeping it improper. We're going to be doing a lot of things in Algebra 2 where we have variables and exponents and all that stuff, and we're going to have crazy looking fractions, all right? And we'll have to reduce a lot of that stuff. But I don't care. I don't want you really to make any of those into mixed numbers for the most part. All right, enough of that. Let's do this. You've heard of this and know this, so I'm going to go kind of fast. Order of operations. What's the one thing that you remember from order of operations? There's like a little word that's not a word. PEMDAS. Yeah, PEMDAS. It seems like only in the last few years people have been saying PEMDAS. Back when I learned it, and a bunch of years when I taught it, we would just say what the stuff stood for. But there's like a little phrase that goes with it. You remember the little phrase? What is that? Please excuse my dear Aunt Sally. Okay? That's what they usually use.
Hi, could you send Nathan Everett down the guidance, please?
I will.
Thank you.
All right, so what does the P stand for in real life? It's not the please. Yeah, so let's write them down. We might as well. Parentheses. It's the third time I've taught this lesson today. In my geometry class, we did algebra review, and this is one of the things we did today in there. What's the second one? Exponents. And then multiplication, I'll just shorten that. Multiplication, division, addition, and subtraction. All right? So that's the order that you do things. It's got like a hierarchy, right? Parentheses is the very first thing you look for. If you got parentheses, do what's inside the parentheses first. Even if a student asked me this earlier today, well, Mr. Hamrick, why'd you do that? Because there was subtraction inside the parentheses. Like, I thought we did subtraction at the end. Why are we doing it first? Because it was where? Where do you think it was? It was inside of parentheses. So even though addition and subtraction is down the bottom of the list, if it's in the parentheses, we always do what's in the parentheses, no matter if it's addition or subtraction. Okay? And then let me do this multiplication and division. Some people get mixed up on this a little bit. If you got a line of stuff that you're multiplying and dividing, all right, you don't always do the multiplication first before the division. You go from left to right. So these should be kind of marked together. You kind of do these together and you do these together. And if you have a situation where you just have multiplication and division, you always go from left to right. Everybody hear that? All right, that's one thing a lot of teachers leave out. I'm an old man, so I'm on Facebook, okay? That's what it used to be. Back in the day, it used to be like the cool thing was Facebook. Like all the college kids were on Facebook, and all the old people and high school kids were on, what was that one thing called? MySpace? You ever hear of MySpace? No, it's called MySpace. You probably never even heard of it. If you have, you probably never got on it. All right. It was before Facebook. It was like the first social media platform. But anyway, my daughter actually set me up with a MySpace. I never used it or anything, but she put a bunch of stuff on there. But I'm on Facebook. People share all these memes all the time. It gets really annoying sometimes. But a lot of times they'll share, and what are you guys on? Like Instagram? Is Instagram a big thing? You probably see this on Instagram as well. You'll see these little memes and little math problems, and it's usually order of operations. And everybody comments, what's the answer to this, And yeah. And if you really know order of operations, you should be able to figure out the answers to those things. But a lot of people don't realize it. A lot of people know to do parentheses and exponents first, and then they know this stuff. But it's this multiplication, division, and addition and subtraction where they get mixed up, okay? Gio, head up, please. So when you have multiplication, division, you always go from left to right. A lot of people will say, oh, do the multiplication all first, then we can do the division. That's technically not really true, all right? You do these kind of at the same time, but if you see them on the same row, you do them from left to right. Same thing with addition and subtraction, all right? So that's pretty important. Let me just do a couple super easy examples. Just want to fly through this. I just can't wait till we get to real stuff. This is not real stuff just yet. It's not fake, but it's just... What if you did this? A lot of people would look at this if they didn't know order of operations. What do you think a lot of people would do if they didn't know order of operations? Yeah, look, they'd probably go 2 plus 4, but we know better there, don't we? So what do? We don't go 2 plus 4 is 6 times 3. What do? We do the 4 times 3 because multiplication comes before addition. So you have to do that first. So you put 2 plus what? 12 equals 14. So that's how you do it. All right? Simple enough. Let's do another one. This one's got some exponents in it. And there's a couple things with exponents we got to talk about as well. B plus parentheses 1 minus 3 to the 4th minus 2. You writing this down?
No.
Yeah, I know. That's why I asked. Okay? I can see out of my peripheral that barely anybody is looking at their paper and writing. So write it down. In fact, come up with an answer. I will give you 1 minute. Get ready, get set, go. You got 1 minute. Write it down and solve it in 1 minute. Gio, you're not writing anything down. It won't take forever. This should have been a common thing you did in Algebra 1. Should have. But I'm teaching it to you now. Or I forgot what time I started. I'll give you 30 seconds. Do the order of operations first. Do what's in parentheses. Then you can do the exponent. You got two exponents. Then you do some multiplication. Then addition and subtraction. All right, you got 5 seconds. All right. There you go. All right, who got an answer? What'd you get?
Connor has the answer.
Connor, what'd you get? What is it? 33. Anybody else get that?
No.
Anybody get something different? Gio, what'd you get? 10? Anybody get that? Yeah? Okay, looks like several people got 10. Let's see which one it is. So here we go. First thing I would do, now it says to do parentheses, but I'm going to do this parentheses and this parentheses. What's the next thing I'm going to do? I'll do this exponent right here, right? All right. So is that okay if I just do that?
Yeah.
All right. Now, there's a difference between this and this. Right here, what are you squaring right here? Are you? Just the 2. Right. The negative is just out in front of it. All right. So on this one, you're only squaring the 2, which is a 4, but you got a negative out in front, so you put the negative out in front. What are you squaring here? The negative and the 2. Okay, so what's negative squared? Negative times negative. Positive. So it's negative 2 times negative 2, which is what? There's a difference, isn't there? Okay. Now, when you have something that's cubed, which we don't have here, but might as well talk about it. What if I had negative 2 cubed and negative 2 in parentheses cubed? They're both negative. That's right. They are. They're both negative. Negative what? What's 2 cubed? 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. This is 8. All right, so this is a negative 8. Same reason, right? 2 cubed is 8, and this just kind of floating out in front. You just put it out in front. But what are you doing here? You're cubing a negative 2, so it's negative times negative times negative. That's an odd number of negatives, which is always going to give you what? Negative. And 2 cubed is 8. You get the same answer. You get it for really 2 different reasons. Okay? If it was 4, if it's in parentheses, it'll be positive. Okay? If it's to the 4th power. Everybody got that? But either one of these ways, if it's an odd power, will always give you a negative answer. Who is that? Okay. All right. Anyway, I just wanted to say that for this. We got to keep going. Plus, let's do this. What's 1 minus 3? Negative 2. And that's to the what power? 4th, okay? We'll do that exponent in the next step. Is that all right? You understand why I did this exponent first? Yeah. Because I knew I was going to have to do this anyway, so I just did it now. What about this? I'd tell you what, I'm going to show you every little step. I was going to say, I think we can do a little bit of this in our head, but I'm going to show you every step, okay? This will be a 1, correct? Okay. Well, let's do this. Let's write down the negative 4. What's this going to be? It's negative 2 in parentheses to the 4th power, right? 2 times 2 times 2, that's 8, times another 2 is 16, positive. So that's plus, plus 16. And then what's this going to be? It's just negative 2 times 1, which is just negative 2. Okay? Negative 4 plus 16, 12. 12 minus 2 is 10, and that's how you get 10. We good? Let's do one more. We talked about absolute value, I think, Friday a little bit. So you kind of do absolute value, like you kind of treat it as if it was a parentheses. It does a little bit more than that, but we'll treat it like it's a parentheses as far as the order of operations. So anytime you have absolute value, you do what's in the absolute value first. Okay, so there's the problem right there. We'll just do it. I won't give you time to do it. So we do what's in here first. So there's a 3, there's a minus, put the absolute value. What's 2 minus 8 in your head?
6.
Minus 6, negative 6. Okay? Everybody with me? All right, now let's apply the absolute value. That PEMDAS thing says nothing about absolute value, does it? But now we're doing it, okay? So it's kind of like parentheses. You do what's right here. Let's figure out what the absolute value is. So I put a 3, put a minus. What's the absolute value of negative 6? It's just plain old 6. So I put a plain old 6 right there. Like Mr. Hammerbeck, it looks like negative 6. Well, where'd that negative come from? That minus right there. Okay? So now what's 3 minus 6? It's negative 3, and that's the answer. All right, enough of that. It's got to get harder than that, doesn't it? It does. Actually, not really. This next thing is not much harder. Let's talk about another word, and it's called terms. What in the world does it mean, terms, when you're talking about algebra? Basically, I'm not going to write the definition down, but I'll read it to you. It says an algebraic expression that's separated by a plus or a minus sign. An algebraic expression basically means numbers and letters. Okay, if you have numbers and letters and you got them all together, even exponents, that would be considered a term. So let me just make some up. So 2x squared, that's called an algebraic expression right there. That's a term, okay? And what if I had this? What if I had 3x squared y to the 5th over 2? That's considered a term. That's one term, okay? Yeah.
Separated by addition.
Right, separated by an addition or subtraction sign, plus or minus, okay? So this is just one term. This is another term. If I had the number like 3, that's a term as well, okay? It's just a term. Okay, what are we talking about? They're one terms, okay? We have a name for one term. They're called, if you have several terms, it's called anybody? Polynomial. Do you remember polynomials? You better remember it after this class is over, or not just today, but this course, because we're going to be talking about a lot of polynomials, all right? Polynomials. So that means how many terms do you have in that expression? So if I just have this, if I just wrote that down, how many terms is that? It's just one, because it's not separated by a plus or minus. Agreed? All right, it's just one thing, all right, that are just being multiplied, squared, all that kind of stuff. So that's a one-term polynomial. We have a name for that. What's that called? Monomial. Very good. Monomial. All right, so that's what? How many terms? One term. So let's just write that down. 2x squared would be considered a monomial because it's just one term. Actually, all three of these, right? That's a monomial. That's a monomial. Okay? What's the next one after monomial? Because mono means one. What means two? Binomial. So binomial. All right, that means two terms. So you must have something in between, right? You got to have a plus or minus in between to get those two terms. So again, I'm just making, let's use these. So what if I said 2x squared plus 3x squared, whatever that is, y to the 5th over 2, all right? How many terms do I have here? I got 2. That's one term. That's another term, all right? Nothing here is being separated by a plus or minus, right? So I got 2 terms. So I call that a binomial, all right? What about the next one? What do we call that? 3. Trinomial, right? So I got a trinomial. That means you have 3 terms. I'll just do the one that I have in my notes. It's not as long. xy minus, what is that, 21? Something like that. Doesn't matter. All right, how many terms do we have here? I got 3. There's 1. There's 2. There's 3. They're separated by a plus or a minus, right? In this case, all minuses. and that would be a trinomial. All right, that's enough of that. Let's keep going because I'm running out of time. Seems like I'm always running out of time. When do we get out of here? 05. Okay, so I got 05, yep. So I got 15 minutes. I got 10 minutes. I'm not going to go through this whole thing. I'm just going to show you the example, okay? They do this definition thing. I don't think you really care. You just want to know how to do these problems, right? So example 4, you've probably seen these before. I'll kind of teach you how to do it within the example. It says evaluate when x equals 2, y equals -3. Well, they throw a fraction in here. Z equals 1/4. So they give you several of them to do. What's that? Okay, so part A, what are we evaluating? We're evaluating this thing right here for part A. We're evaluating x squared plus y minus z. Now, they tell us what x is equal to. They tell us what y is equal to. They tell us what z is equal to. So, give me a good word. If I take this and I put it in for x, what do we call that phrase or that word in math? Substitution. Very good. So, we're substituting what x is equal to. So, what are we going to do here? So, x is what? Yeah, they tell you that, okay? We didn't have to figure that out. They told us that, and we want to figure out what this thing right here is going to equal if x is equal, y is equal, and z is equal to those certain things. So I put a 2 in for this. But what's happening to that x? It's being what? It's being squared, so I got to square that too. What if, well, what if that x was -2? Would I just put a negative like this? What would I have to do? Right, I would have to put a parentheses around it because I'm squaring the entire -2. But it's not a -2, is it? So, oops. So we don't have to worry about that. So that's the first part. Plus what? Plus y, which is -3. Minus what? 1/4. And now we just do the math. We solve for it. What's 2 squared? Let's do a little bit in our head. What's this? Can we do that in our head? 4 plus -3, which is what? 1 minus 1/4. What am I going to write 1 as? 4/4 minus 1/4. And what is that? What is that? 3/4. That's it. That's your answer right there. You've done those. You did a ton of those last year, didn't you? Well, not last year, 2 years ago. It's been a while, but we probably did something like that in geometry as well. They give you 4 examples. I'm not going to do them all. You mean just jump to the part D? Because that's usually the hardest one. What's that? Nah, let's do this one. Because if you can do this one, you should be able to do B.
It says evaluate when x equals 2.
All right, there it is right there. I'm not going to give you time to do it because we're running out of time, so let me just do it for you. Here we go. But you should be writing this down, okay? You should be writing down what I write down. So put a 2, put a parentheses. What's the x? 2 plus -3, close the parentheses, minus, now these, what's happening to the y and z right here? They're being multiplied together. So y is -3, z is 1/4, plus z squared. It's positive, so do I really need to put it in parentheses? No, not if it's positive. If it was negative, yeah, it'd be really important to do that, but I can just do it like that. If you want to put it in parentheses, it's fine. All right, what do we get here? This is 2 times what? -1. Minus a negative. What's minus a negative going to do for us? It's going to be what? Come on, think. What's minus a negative? It's plus, right? So you know that's going to go to plus. And what's 3 times 1/4? 3/4, right? Simone, you getting all this? Didn't think so. Plus what? Just watch. Just keep your eyes open. It's very demoralizing for me. It really is. When I see heads down, it's so demoralizing. It makes me feel bad. I cry. I cry my night away. All right, so what do we got here? This is what? -2? I'm going to put it over 1. Is that all right? Because I got fractions over here. And now I just have to add fractions. You're lost already? Well, write the steps down. I showed you every little step. So what do we get here? Common denominator, 16. All right. So what'd you do? We did this once before. We'll go a little quicker. 1 times what? 16. Negative 2 times 16. Negative 32. 4 times 4. Okay. 3 times 4. 12. 16 times 1. 1. Boom. 1 right here. 16 times 1. 1 times 1. Okay. Yeah? Did I do that right? Yeah, I did that right. All right. So here we go. Everything is over 16 now. So we just add these up. Negative 32 plus 12. What's that in your head? Negative 32 plus 12. Subtract. Take the sign of a larger number. Subtract those two numbers from each other. It's just 20. It's negative 20 though, right? Because 32 is bigger. So what's negative 20 plus 1? How about negative 19? Okay, that makes a difference. That's your answer right there. If you wrote it down, if I went too fast for you, I realize I did go a little bit quick just because of the time, but at least I wrote it down. It's on YouTube, right? Go back and watch it. Slow it down, pause it. Make sure you understand why I did all those steps, okay? We just got to get to the end, and we're almost there. And I got less than 5 minutes. So let's get this done. All right, they do this. Example 5, they use this temperature conversion. This is almost a waste of time anymore because if I need to find if I want to go from Fahrenheit to Celsius, I just plug in my phone in Google, what's 83 degrees Fahrenheit in Celsius. Boom, they tell you right away. But this is how they do it. All right, so I'll give you 2 formulas. Don't pack up. I can see it out of my corner of my eye. What do you think the C and the F stand for? Celsius and Fahrenheit. So if you know it in Fahrenheit, you want to figure out what it is in Celsius, you can always put it into that little formula. I have a little story for this, but I'm not going to tell it because of time. All right, so there's the 2 formulas. Do I have these memorized? No. Should I have them memorized? Probably as a math teacher, probably should, but I would use Google anyway, all right? So, A. So I want to change 15 degrees Celsius, 2 degrees Fahrenheit. Okay? Everybody watching? I want to change it to Fahrenheit, which means I know what the C is, and I want to change it to the Fahrenheit. Which one am I going to use? The first one or the second one? The second one, right, because I want to change it to Fahrenheit. So let's do it. So Fahrenheit equals 9/5 times C. What's C? 15. Now they picked a number to make it kind of easy, plus 32. Let's do this. 5 goes into that once. It goes into that what? 3 times. 9 times 3 is 27 plus 32. What's that? 59. Yeah. So, we usually know Fahrenheit, so if it's 15 degrees out, and a lot of people will go by that. There's people in this school that have come from other countries that use Fahrenheit. We're like the only ones in this world, I think pretty much in the world. I think there might be 1 or 2 other countries, but really small, tiny countries. We're about the only ones that use Fahrenheit, all right? Pretty much, all right? When I lived in Australia, I told you I lived in Australia. I lived in Australia in 1973, 74. They were just starting to change over to the metric system. They had just started changing over. So they just changed the speed limit signs, right, to kilometers per hour. People started talking about Celsius instead of Fahrenheit and all that. And that was 1973. And here we are in America. Everything's still miles per hour. Everything's still feet and inches. But we are slowly, very, very, very slowly. What's something that you probably see almost every day that's in metric?
Meters.
Do you see meters? Where do you see meters? Like in your refrigerator. Liters, right. Right? If you have a 2-liter bottle, you know exactly what that is, don't you? Here's your homework. So this is your homework. Yeah, it's the same thing. But and if you already did it, Great. I'm just writing it down.
Yeah.
We did.
There it is. 1 to 35 odds. That's your homework. It is due tomorrow.